This is step 1, 2011, question 11. So we're told that we have a thin, non-uniform bar, AB, of length 7d. It has a centre of mass at the point G, where AG has length 3d. A light, inextensible string has one end attached to P and the other end attached to B, and the string is hung over a smooth peg P, and the bar hangs freely in equilibrium with the end B lower than the end A. I'm going to just draw the forces on this diagram. Have a go at doing that yourself first. So we've got weight and tension. And now the first part of the question asks us to show that 3 sine alpha equals 4 sine beta. So we've got the angle alpha here, which is defined as PAB, and the angle beta here, which is defined as ABP. So first thing to do with systems in equilibrium is consider two things. There are two things that we should consider doing. That is, resolve forces or take moments. So in this case, we're trying to show that 3 sine alpha equals 4 sine beta. So what do you think the best thing to do is? Pause this video and have a think yourself. We should take moments in this case. Why? Because we don't want the force weight involved. And we see that there is a 3 and a 4 here, which kind of corresponds to the lengths, and moments involve taking the length times the force. So we want to take moments about G, which is where the centre of mass lies, to avoid weight completely. So when we take moments about G, we've got this force T sine alpha and T sine beta here. So we get 3 dt sine alpha equals 4 dt sine beta. Cancelling the dt's, we get 3 sine alpha equals 4 sine beta as required. So given that cos beta is 4 over 5 and alpha is acute, find in terms of d the length of the string. So I've labelled the length AP x and the length PB y, and we want to find what x plus y is. So what did we learn in the previous part of the question? We got a relationship between the sines of alpha and beta. So to work out lengths of this triangle, so we have this triangle here, APB, and we've got two angles, and we've got two sides that are opposite the angles. So it might be a good idea to use sine rule, and we can find a relationship between these two sides. So using sine rule to find a relationship between AP and BP, we get x over sine beta equals y over sine alpha. So x sine alpha equals y sine beta. And we know from before that 3 sine alpha equals 4 sine beta. So subbing this in, we get x times 4/3 sine beta equals y sine beta. So x equals 3y over 4 as our relationship between x and y. And this will make the next part of the question easier to deal with. Okay, so summarising what we have, we know a relationship between the lengths x and y and a relationship between the sines of alpha and beta. So we've used sine rule on the sides AP and PP to relate them, but now we want to relate them to the side AB. So a good idea is to try and work out this angle APB, so we can use sine rule here, or the sine of the angle APB, sine APB. The first thing we need to do is consider what cos beta equals 4 over 5 mean. And if you recognise this is very reminiscent of a 3-4-5 triangle. So from this we can work out that sine beta is 3 over 5. And if you remember the relation 3 sine alpha equals 4 sine beta, we can then conclude that sine alpha is 4 over 5. And then from this we work out that cos alpha is 3 over 5. So we got these here. And now we want to work out sine APB. So sine of angle APB is sine pi minus alpha plus beta. And remember that alpha plus beta is acute and less than pi, in fact, because it's in a triangle. And if we look at the sine graph, we see that it's symmetrical by pi by 2. So doing sine pi minus alpha plus beta will just simply give us sine alpha plus beta. And if we expand this out using compound angle formulae, we get sine alpha cos beta plus sine beta cos alpha. And that's perfect because we know the values for each of these individually. So putting the values in, we get 4 over 5 squared plus 3 over 5 squared. So that's 16 over 25 plus 9 over 25, which is 1. So we know that sine of angle APB is 1. And so we can conclude, since APB is less than pi, that APB is pi by 2. And so, now we know that the angle APB is pi by 2. We have triangle APB is a right angle triangle, and we can use Pythagoras to work out the relationship between the side AB and the sides AP and PB. So have a go at doing this yourself, and remembering the relation from before that we have x equals 3y over 4. Okay, so applying Pythagoras rule, we get 3y over 4 squared plus y squared equals 7d squared. And that's by substituting 3y over 4 as x here. And then expanding that out, we get 9y squared over 16 plus y squared equals 49d squared. So that's 25y squared equals 784d squared, multiplying up by 16. And then we get y squared equals 784d squared over 25. And then square rooting both sides, y equals 28 over 5d. So how can we find x from here? So we know the relation from before that x equals 3y over 4. And so x is 21d over 5. And hence the length of the string, which is x plus y, i.e. the sum of the sides AP and PB, is 49d over 5. Just a quick note that in the next scene I've drawn this diagram on the left. This is labelled wrong. In fact, it should be this diagram on the right. The side AP should be 21 over 5d and the side PB should be 28 over 5d instead of the 21 over 7 and 28 over 7. So just bear this in mind in the next scene, but it should be fine because we're not using these lengths anyway. The last part of the question we're asked to show that the angle of inclination of the bar to the horizontal is arctan 1 over 7. So looking at this system that we have here, our system is in equilibrium. And at the start of the question, looking at a system in equilibrium, we identified that there are two things that we must do to find as much as much information as we can about the system. So let's think about that again. So the system is in equilibrium. What haven't we done so far? So we've taken moments, and what's left to do now? That's right, we need to resolve forces. And for this system, because it's at different angles to the horizontal, we could do this in different ways. We could consider resolving forces parallel and perpendicular to the bar, or horizontally and vertically. Now, I'm going to resolve forces parallel and perpendicular to the bar, and that way I'm not going to involve compound angles such as beta plus theta or alpha plus theta, but you're very welcome to resolve forces horizontally and vertically to the bar. Horizontally and vertically, because that will also work. So let's add these forces in. So we've got tension acting in the string and weight acting on the bar at point G. So we've got weight and tension, and I've drawn the components of weight here. And now we're going to resolve parallel to the bar first of all. So resolving parallel to the bar, we've got a component of weight, W sine theta, acting down the bar, and we've got a component of tension acting down the bar, and a component of tension acting up the bar. So we have W sine theta plus 2 cos alpha equals 2 cos beta. So W sine theta is T over 5. And why do we know that? Because we know our values for cos alpha and cos beta from this table here, from what we've worked out in the previous question. So now resolving perpendicular to the bar, we've got our component of weight acting down and our components of tension acting up. So W cos theta equals T sine alpha plus T sine beta. So that adds up to 7t over 5. So now we've got an expression for W sine theta and an expression for W cos theta. Can you think of a way to calculate tan theta from this? So W sine theta over W cos theta will give us tan theta is 1 over 7. And finally, we can say that theta equals arctan 1 over 7, as mentioned in the question above. And then that's the end of the question. Just a final note on this question that there are quite a few different approaches to each of the parts of the question, especially with mechanics and geometry problems. You can use different trig rules or different ways to resolve forces. So if your approach isn't mentioned here, don't be alarmed. If you reach the right answer in a correct way, it should be entirely valid. And similarly, if you want to look at all the different approaches, have a go exploring them, looking at different ways of resolving forces and different ways to find the side lengths AP and PB.